In today's note, we are going to continue to look at factoring, and in particular, we're going to be looking at what we call common factoring first. So we're going to, just as a review, expand the following using box or FOIL method just to get an idea of what we're looking at. So I'm going to do one in each. So in the first one, if we use the box method, here, let's multiply our two binomials first. So x, let me draw my box, sorry. So x and 6, x and 3, we get x squared, 6x, 3x, and 18. So that works out to x squared plus, again, remember, add up those diagonals, 9x plus 18. And the only thing we're missing, though, right now is this 2. So this 2 just comes down, and we still have to multiply now everything by 2. So when we multiply everything by 2, we get 2x squared plus 18x plus 36. And this is my expanded form. In the second example, let's use FOIL method. So I'm going to multiply my binomial, or my two brackets, using FOIL. The 4 is still going to stay out front and multiply whatever my answer is. So I have x squared minus 6x minus 2x plus 12. Let me simplify what's in the brackets. We have x squared minus 8x plus 12. Now this 4 has to get multiplied into every single term. Similar to how in the last question that 2 got multiplied into every single term. So in this case, we end up with 4x squared minus 32x plus 48. So again, that's how we multiply or we expand when we have a bracket or two brackets and a value out front. And basically what this bracket or what that value ends up becoming, it ends up becoming what we call a common factor. And a common factor is a value that can be multiplied into every term. So we see here that common factor of 2 and 4, that was multiplied into every term. So I could divide out that common factor, or basically we could common factor out that multiple. And that's what I'm going to work on in this lesson. So if I want to fully factor this example, y equals 2x squared plus 12x plus 10, I need to do something first before I can use the methods that I learned in the last lesson. And the thing is, the reason for that is because of this value in front of the x squared. That's a little bit different than what we looked at before. But we see that in the last ones, that value in front can possibly be a common factor. So the first thing I want to do now, in step 1, is divide out that common factor. Right? So if we look back at our previous examples, I want to go from here back to here. Right? So I need to divide out that common factor. So the common factor in all of our general cases is going to be the value in front of the x squared. So in this case, the 2. So the 2 is going to go outside my brackets. And now to figure out what goes inside, I need to divide everything inside the bracket by 2. So 2x squared divided by 2 is x squared. 12x divided by 2 is 6. 10 divided by 2, 6x, 10 divided by 2 is 5. So when I divide out my common factor, or divide by that common factor, this is what I end up with. Now what I can do, I can factor it. I can factor this bracket, right? Whether we use the reverse box method or we use the product and sum method. Because we have two examples, I'm going to go through each. So we know that our first term has to be x squared, so that's going to be up here. I know the bottom one has to be 5. The first terms, or the first part of my brackets, both have to be x, because that's the only way I can get x squared. Now I'm looking for two numbers that multiply to 5, and they have to add to that middle number or these two boxes have to add to 6, or 6x. Well, the nice thing is the only two numbers that multiply to 5 are 5 and 1. And because it's a positive 5, both of these numbers have to be positive, or they could be negative, but because they have to add up to 6 or positive 6, my two numbers 5 and 1 should be positive. So if I fill in my box, x times 5 is 5x, x times 1 is 1x. If I check, do those two numbers add up to 6x? Yes, they do. And we know 1 times 5 is 5. So that means then, when I factor this again, or when I write it out finally, I have x plus 1 times x plus 5. And that comes from my box method. However, there is something missing. And the thing that's missing is that common factor that I divided out. So really, what I need to have still is that 2 in front. So my factored form is y equals 2 times x plus 1 times x plus 5. And if we wanted to expand this or use the box method or FOIL method, we should work back to something that we get or that we started with. So if we expand, that's what we go back to. Now that I have it in factored form, I should be able to state what my roots are, or my x-intercepts, which in this case are the opposite of what we see in the bracket. So in this case, my x-intercepts are -1 and -5. As an additional question, if I wanted to find the vertex, and so again, this is all stuff that we've done with factored form, so you might have to go back and review those lessons. But if we wanted to find the vertex, we need to find the x value of our vertex, which is in the middle of these two x-intercepts. So to find that middle value, I have to add up my two x-intercepts, divide by 2. So I get -6 divided by 2, or -3. Now that I have that value, I'm plugging it into the equation for x, and then I'm going to solve for y. So -3 plus 1, -3 plus 5, y equals 2 times -2 times +2, or y equals -8. So because I have an x value of -3 and a y value of -8, my vertex for this quadratic is -3, -8. We're going to do one more example B, and I'm going to do this in the product and sum method. So the first step, though, I need to divide out that common factor. In this case, that common factor is going to be the value in front of the x squared, which in this case is -3. So y equals, the -3 is going to come out front, and then inside my bracket, every term is going to get divided by -3. So the first term will be x squared, 6x divided by -3 is -2x, and +9 divided by -3 is -3. Now that I have my common factor divided out, I can factor everything that's in the bracket. And I'm going to use my product and sum method. So this means I'm looking for two numbers that multiply to -3 and add to -2. And if we think about what those two factors have to be, well, the only numbers that multiply to -3 are 3 and 1. One of them has to be negative, and the only way that it will work out that they add to -2 is if the 3 is negative. So my two factors are going to be -3 and 1. That means then, when I go back to my equation, I get y equals -3, x is in one bracket with -3, x is also in the other bracket with +1, or just my two factors. And that -3 just gets carried down, right? So we don't lose it, it just stays and gets carried down. This means then that my roots or x-intercepts are again opposite of what we see inside the bracket, which is positive 3 and negative 1. And if I want to determine my vertex, I'm going to do the exact same thing. Find the middle value by adding up my two x-intercepts, so 3 plus negative 1 divided by 2, 2 divided by 2, which equals 1. Once I find that x value, I'm plugging it back in for y, so y equals, or sorry, not for y, for x, and I'm going to solve for y. So y equals negative 3, 1 minus 3 times 1 plus 1. Y equals negative 3 times negative 2 times 2. Y equals 12. So now I have my x and my y value, so that means my vertex is 1 and 12. So we have two more examples. Again, the same idea. We want to fully factor them by dividing out the common factor, then factoring them by either doing the reverse box method or the product and sum method. State the roots, determine the vertex, and sketch the graphs. So I'm going to suggest that you pause the video to try this on your own, and we'll come back with our full solutions. But again, I do recommend trying this on your own. Same steps as what we did in the last example, right, by dividing out that common factor and then factoring whatever is in the brackets. How you choose to factor it is up to you. When we come back, you'll see that we'll have done one example in reverse box method and one example in product and sum method. So coming back and looking at these two examples, these are your solutions for the last two examples. So we're going to work through the first one or just explain what we did. So we should have found that the common factor was 2. So if I divide 2 out, I bring the common factor out, and then inside the bracket I have x squared plus 2x minus 3, or basically my entire expression or equation before, all divided by 2. I then factor it using reverse box method. I should find that my two values that fill in the rest of the box, x and x, make the x squared. Because I have to multiply to negative 3, or this bottom box here, I need to have 3 and negative 1 to add to that plus 2. So then when I factor it, the 2 comes down from the common factoring, it still stays there, and my two brackets are x minus 1 and x plus 3. So my roots are the opposite of what I see in those brackets, so positive 1, negative 3. To find the vertex, I find the middle value of those two x-intercepts to be negative 1. I take that value, plug it in to the equation for x, and solve for y and get negative 8. When I go through and I plot this, I can plot my vertex because I have that point. I can plot my x-intercepts because I'm also given those points because those are my roots. As well, if I wanted to, I could plot the y-intercept because the y-intercept comes from the last number in my standard form equation. As well, if I wanted to, I could use the step pattern because looking at my general form, if I go back up, whether it's in standard form, or sorry, factored form here, or whether it's in standard form here, that's my a value, which tells me the stretch, or sorry, the step pattern. So the step pattern is 2, 6, 10, so I can go over 1 up 2, over 1 up 6, over 1 up 10. So actually we should write that down, the step pattern, 2, 6, 10. And then I can sketch my graph and use symmetry. For the next example, even though I don't see a value in front of the x squared, I do see a negative or a negative 1. So I need to factor that out because the only way that I can factor in the previous lessons is if the value in front was 1. So negative 1 is different from 1, so I do need to factor that out. So that -1 comes outside of the brackets. Everything else gets divided by -1, which basically means I just switch the signs. And I end up with x squared minus 4x plus 3. In this example, I used the product and sum method. So I was looking for two numbers that multiply to 3 and add to -4. In this case, those two factors were -3 and -1, so they both go into two separate brackets with x. So our factored form is y equals -1 that got carried down from the common factoring, x minus 3, x minus 1. My roots, or my x-intercepts, are the opposite of the numbers in the brackets, so +3 and +1. To find my vertex, I found the middle of those two x-intercepts, which happened to be 2. I then took that x value, plugged it back into the equation for x, and solved for y. And I got that the y value of my vertex was 1. So my vertex ended up being 2 and 1, which I could plot on my graph. I could also plot my two x-intercepts. I could plot the y-intercept, again, because again, that's the last value in our standard form. And I can use that a value to help me find my step pattern, which was -1, -3, -5, to help me find my other points so I could roughly sketch it. So again, the main thing here is the common factoring and getting it down into a form that we can factor using the methods we learned in the previous lesson. Everything else, such as stating the roots, determining the vertex, and sketching the graphs, that all comes from what we should have learned previously about quadratics. So you may need to review some of those lessons just to get a refresher, but the main thing is, or the newest math or concepts that we've looked at, is the idea of common factoring first and then factoring to get our standard form into factored form.